Hi, I am Michael Beck, and I am an Enterprise Support Manager at AWS, and I'm based out of San Francisco, California. Welcome to AWS Knowledge Center Live, where we share best practices and troubleshooting tips from AWS Support. Joining me today is Aiden Beckeroff and Louise Fox from AWS Support. Can you give us a quick introduction, Aiden?
Hi, my name is Aiden, and I'm an enterprise support lead and senior TAM in San Jose, California. This topic's really interesting to me because best practices keep evolving as features and capabilities are released, and keeping customers well architected and secure is a really big part of being a TAM. So I'm excited to share some knowledge here and on a really important AWS service.
Hi, I'm Louise. I'm a cloud support engineer from the Dublin team, and I work directly with customers using the IAM service and helping them with their overall security posture.
Thank you, Louise. Our topic today is AWS Identity and Access Management Best Practices, which you'll probably hear us refer to a lot today as IAM. And IAM enables you to manage access to AWS services and resources securely. Aiden, can you walk us through in a little more detail what we're going to be talking about today?
Yeah, thanks, Michael. So we'll cover the top best practices as of 2021 to keep your AWS environment secure, along with a couple quick IAM users and roles demos. And if we have time at the end, a demo on using AWS config for governing out of compliance IAM configurations. So we'll also give our recommendations on common design decisions. And we jumped a couple slides ahead here. Let's head back to the agenda here. But we'll also cover our design decisions, some common questions we get from customers, like, should I be managing users, IAM users in IAM, or federating in from an identity store? And what's the right balance between them? Or should I be deployed in one AWS account or within multiple AWS accounts? And what's the recommended multi-account strategy? And how do I best accomplish cross-account access? So, doing direct cross-account access role assumptions or building a hub and spoke model with a central identity account. So, and other topics here. But with that said, let's jump over to Louise here for a refresher.
Thanks, Aiden. Sorry about that technical glitch there. So to start off, we're just going to do a refresher on exactly what identity and access management is. So could we just get a virtual hands up in the group chat for anybody that's new to AWS or new to IAM? Okay, yeah, I see a few up there. So basically what IAM does is it's a free service that enables you to manage access to your Amazon Web Services and resources securely. It's basically to control who can do what in your AWS account. So using IAM, you can create and manage users, groups, and roles and use permissions to allow and deny their access to resources. So to start, you have an IAM user, which represents the person or service who is interacting with your AWS environment. And this consists of a name, a password to sign into the AWS Management Console, and up to 2 access keys as well to interact with the API or CLI. You also have groups. So this is basically they're used to specify permissions for a collection of users with the same responsibilities, making those permissions easier to manage. An IAM role is similar to a user, but instead of being uniquely associated with one person or service, a role is intended to be assumed by anyone who needs it. So rather than having long-term credentials like passwords and access keys associated with it, a role can be assigned to a federated user who signs in using an external identity provider instead of IAM. You also have principals. So a principal is used in a resource-based policy or a role trust policy to specify access to a resource. The principal can be specified as anything: a user, a role, a federated user, AWS service, root user, or a whole AWS account. And lastly, you have permissions. So permissions let you specify access to AWS resources. Permissions are granted to IAM entities, users, groups, or roles. So centralized. IAM is a centralized service, meaning that you can set up all of your permissions in one place. You don't need to go to S3 console to set up S3 permissions or the KMS console to set up KMS permissions. It can all be done from the IAM console, and it's fine-grained, which means that you can specify permissions down to API level, down to resource level. You can actually also use conditions for more granular control again, which Aiden will discuss later on. And secure, deny by default. So yes, this means that when you first create an IAM user role, it starts with no permissions. So in other words, IAM entities can do absolutely nothing in AWS until you grant them your desired permissions. Deny by default until you explicitly allow. So here are some examples of IAM policies. So the one to the left is a resource-based policy, and the one to the right is the one to the left is an identity-based policy, and the one to the right is a resource-based policy. So here you see on the left, effect, action, and resource. And this is just a helpful hint for reminding you how to actually create the policy. And what this policy does is you attach it to an IAM user or role, and it allows all IAM describe actions for all resources. And then here to the left, you have the resource-based policy. And what this does is you attach it to a resource, in this case, an S3 bucket, and you specify the principal, which I mentioned earlier. So in this case, it's a whole AWS account. And what this policy is allowing you to add an object to an S3 bucket if this condition is met, which means that the ACL of the object has to be public read, but when you're adding it to the bucket. So that's the difference there between the two types of policies, but we'll delve into more on this as well later on.
And Louise, I wanted to give a plug for one of my favorite reInvent videos from 2018 on become an IAM policy master in 60 minutes or less. So, if someone's tasked you with auditing hundreds or thousands of IAM policies, or you yourself want to tighten up your policies, definitely give that video a watch and, become a policy master in 60 minutes or less.
Very cool. So onto our IAM demo here, where we're going to be creating an IAM user and a role. So to get started, we're going to create an IAM user. So here we go, add user, and you're adding a user here. This user has to be unique within the AWS account. So as you can see here, the username was already taken. So I'm just going to go ahead and add user to the end of that. And next, access type. So you can add programmatic access, or you can add console access. So programmatic access is where you basically get an access key ID and a secret access key to interact with the API or CLI. And you can have up to 2 of those for a user. And console access is where you generate a password and your username to authenticate into the console. So with this, you can have auto-generated passwords or custom passwords. And in this case, we'd usually recommend an auto-generated password, just because this means that the administrator who's actually creating the user isn't going to be using their own password or a password that they know. So it's just more secure. And you can also require a password reset, which means that the user will be prompted to create a new password when they go to log into the console for the first time. And when this happens, we have to add the IAM user change password policy to the user so that they're authorized to actually change their own password. So moving on here to permissions, you can add a user to a group, which I mentioned earlier. So a group is basically where you have a collection of users and they all have the same responsibilities. So for example, if you want to add your user to the admin group, you can add them all to that and they will all inherit the same permissions. And this way, if you want to make any change, it's so much easier in terms of organization, just because you can actually change for all users. Or you can attach an existing policy. So here you have customer managed policies and you have AWS managed policies. So the difference is that an AWS managed policy is created and managed by AWS. And whenever there's any changes at all, AWS manages all of this. So they're free to use and there's multiple policies for every service. And then a customer managed policy is a policy that is created by you. So it can be more custom to your use case. And you might have it for, whatever suits your use case, basically. So for this, we're looking up config, and we are going to attach a config managed policy for the sake of this. So as you can see here, these are all config policies, and we're going to attach the AWS config user policy. And we're also going to attach a CloudWatch policy. So as you can see, there's loads of policies here. So there we go. Sorry, I think there's another glitch there slightly. So now we're attaching a CloudWatch policy again. Sorry about that. So CloudWatch full access, there we go. And next down to permission boundaries. So this is an advanced feature of IAM where basically you can set the maximum permissions that a user can have. So how this will work is that if you attach CloudWatch full access as your permission boundary, just as an example, it means that no matter what permissions are added to your user, only CloudWatch full access is actually what your user is the maximum permissions that your user can actually have. So that can be really convenient for different use cases. You can add tags if you're interested in tag-based access control. And here you go, just to review your user that you created, programmatic and console access, auto-generated, and here are the 3 policies as well that you've attached. So you can go ahead and create that user. And it should be created within seconds. Yeah, there we go. And here's all of the credentials that's been generated that you can download in a CSV file. And over here is a custom sign-in link as well that you can actually create your own custom sign-in link for your users. So quickly moving on to roles. So creating a role, there we go. So there are 4 types of trusted entities that you can have when you create a role. So the first, basically a role can be assumable by anyone and also non-human things like EC2 instances. So this means that an AWS service can perform an action on your behalf without any manual intervention by you. And here is a full list of all of the services that support this. Next, another AWS account. So this is where another account can perform actions in your own account. So this would be really handy if you have a multiple account set up like AWS organizations. Next, you have web identities. So this is good if you manage user identities outside of AWS, and you can use IAM identity providers instead of creating IAM users in your AWS account. So with an identity provider, you can manage your user identities outside of AWS and give these external user identities to permissions to use AWS resources in your account. So this would be really useful if your organization already has its own identity system, such as maybe a corporate user identity, or maybe you're using Amazon Cognito for web authentication. And lastly, SAML 2.0. So this is where you can allow your users that are federated with SAML 2.0 to assume a role in your account. So for this example, we're going to go with another AWS account, and I'm going to specify the account ID here. And next, require external ID. So this is a piece of data that you can actually specify, and it will be passed with the assume role API to designate who can assume the role. So to provide an external ID, when you assume the role, you have to use the CLI or API. And when you need to grant access to your AWS resources through a third party, using an IAM role with an external ID is a best practice. And also here we have require MFA, multi-factor authentication. This is another layer of security for your account as well. So that's another best practice. So next, moving on to permissions. And here, same as using a user, you can add permissions as well here, custom or manage permissions. And also you can set a permission boundary. So yep, the same thing, an advanced feature of IAM for setting maximum permissions. Just for the sake of this, we're going to use administrator access, and you can add tags again if you wish. And here's where we define the role name and just review all the settings and configurations that we just made. So again, I'll call this role, there we go, and create role. And your role will be created within seconds again. And there we go.
Thanks, Louise, for that demonstration. We do have a question from the audience, which is from Princeton Girl 21. What is the difference between managed and inline policies?
So the difference there is that a managed policy is created and managed by AWS. So this can be really convenient if you're new to IAM and you're not sure of where to start. And also it means that if any service or API is being introduced after you created the policy, AWS manages all of that for you. And then there's also, there's custom and there's managed policies. They're both under that title. And then you also have inline policies, which are basically a one-to-one relationship with IAM. So this might be convenient, for example, if you have a user that you want to have a very specific policy only for that user and you don't want the policy to be added to any other user or role. This would be a really good reason to use an inline policy. And it also means that if your user or role is deleted, the inline policy will be deleted with the role as well. We'll actually go more into this throughout the session.
All right, great. Thank you very much.
So moving on to top IAM best practices. So for starters, the root user. So we always recommend to reduce or remove the use of the root user. A root user is when you first create an AWS account, you begin with only the root user, and this user has complete access to all AWS services and resources in your account. We strongly recommend that you do not use the root user for your everyday tasks, not even administrative tasks, just to reduce the potential for misuse of credentials. Also throw away any root access keys that are used with the CLI or SDK, just again to reduce any security risks or mistakes. And there are only certain tasks that require root user credentials, such as changing your account settings, closing your AWS account. So these would be the only reasons that we recommend using root. MFA, so enable MFA for your users. The MFA is what I mentioned earlier, multi-factor authentication. It's an additional layer of security to prevent any unauthorized access in your AWS account. So your users will then have their username and password, which is something that they know, as well as an MFA token that generates one-time passwords, something that they have. So it supplements authentication, and you can have hardware or software MFA devices for your users and roles. Users, create individual users. This is recommended to enforce separation of duties. So basically separate credentials for different jobs. So that way there's no elevated unnecessary permissions. Yeah, so unique credentials for your users. Unique individual credential rotation means that your users have control over rotating their credentials, and individual permissions. Roles, use roles for short-term credentials. We always recommend using short-term credentials where possible. It means that credentials will not need to be stored and they will expire after a specific amount of time. So you can create an IAM role that has different permissions assigned, and users can assume these roles to carry out tasks. As well as AWS credentials, users can authenticate into roles using like federation, things like that. So there's no need to share credentials, there's no need to store credentials, and it can be used for cross-account, intra-account delegation, and federation. And permissions. So another security best practice of ours is always granting least privilege, which basically means rather than full access, only grant what's needed. So with IAM, as I mentioned before, it's fine-grained. You can specify services and resources, and this means that there's less chance of anyone making mistakes, and it's more granular control. Over to you, Aiden.
Thanks, Louise. So next best practice to really talk about is the use of conditions. And conditions really restrict the privileged access further. And it's an optional element. If you recall that JSON text, JSON code before, it's an optional element of the IAM policy. It really helps you tighten the effective permissions. And when you hear somebody say, I only want to grant access to something, that just screams the use of a condition. Conditions can be built with condition operators. So that's like equal than or less than to match the exact key and value. So key could be like string equals EC2 instance type. Value can be like T4G, the test instance, say, just in your development account. And this is great. This can be enabled for any AWS Service API, and I strongly recommend use of conditions to really tighten your policies down. Next is using groups, really. So you might be seeing a trend here. The easier something is to manage, the more secure and less chance of errors you have to make here. And a group is just a collection of IAM users, and it's a way to attach policies to multiple users at once. And this allows you to manage access centrally by changing just a group's membership instead of updating, say, all the individual policies when a user needs access to be changed. So definitely use groups in your IAM usage here. Next, if you have to configure a password, which for console access, we'll talk about password usage shortly. But if you have to configure it, configure a strong password policy. And that means things like setting a minimum length, having high password strength, an expiration, and preventing reuse and more. There's actually even more options to select for a password policy in IAM, and this all helps prevent prevents you from compromise and from your data. It protects your data essentially. So use a strong password policy. Next is to rotate your credentials regularly. If you do have long-lived credentials, like access keys and passwords, and you can't use roles, that automatically rotate, make sure you are rotating regularly. So that reduces the whole business impact if you're compromised. And we recommend using another service, AWS Config. It has a managed rule to check for your credential age. And we'll also talk about this in monitoring and how to make sure you are actually rotating if you think you're rotating. So lastly, here is to monitor. Definitely be monitoring your IAM access and usage. So we provide a whole host of purpose-built tools for this, like Access Analyzer and CloudTrail and CloudWatch, to give you, alarms and alerts and awareness about this. But one of my favorite things about the cloud is that you have full environmental access awareness. There's no more hidden computer under a desk somewhere in an office, because you can now enable full traceability and accountability of all of your access to resources. So we'll also cover that shortly in monitoring versus remediation. But yeah, that's it for me for a sec.
Thanks, Aiden. So what we're going to go through now in this session is basically design decisions, as Aiden mentioned. So when to use what in your account. And it's not even often use one over the other. It can often be used both. So it really depends on your use case. Here we have several frequently asked questions from our IAM customers. So we plan to go through each of these with you and help you understand when to use one over the other or when to use both. Before we go ahead, Michael, is there any questions in the group chat?
Hi, Louise. Yeah, we do have a few questions going on here. We had Joe Desmond asking about what happens if you lose or break your MFA device, and I was able to link them to an article about that, in which they would have to possibly work with their account owner, because they'll need access to the email and the phone number that was used to register that account.
Actually, just to add there,
yeah.
If your IAM user or role that actually, we'll say, loses or breaks their MFA device, if you just contact your administrator, they should be able to actually deactivate it for you, and then you can just re-enable it again. It's more if it's your root account or an administrator user, that we do have a dedicated MFA team that you can fill out a form and they should call you. So yeah, as Michael said, you need to have a phone number ready for that, but yeah.
And then there's another question going back to the policies. I don't know if you're going to be covering this later or not, but the spec 007, with regards to policies, can you please tell me what is the difference between global and service specific conditions?
Aiden, do you want to?
So on global condition keys, I don't have a smooth answer for this one, actually. Louise, do you want to give this one a stab?
Yeah. So basically, global conditions are conditions that can be used by loads of different services, as long as the services actually support them. And they usually start with a prefix like AWS, where service-specific conditions are created specifically for those services. So for example, we'd have a lot of conditions that are specific to EC2 only. So they would have a prefix of EC2 in front of it, or RDS might have service-specific conditions with RDS in front of it. So the difference is that you can use service-specific conditions for the service they were created for. You can use global conditions for multiple services as long as the service supports. So we have loads of documentation on what's supported and where per API, which we can add into the group chat as well.
All right, great. Thank you very much.
Okay,
cool.
On to Aiden.
Yeah, thanks, Louise. Thanks, Michael. And thanks to the audience for your questions. Let's hit one of my favorite topics here on IAM users and federated users. And overwhelmingly, I recommend use federated users where possible. Federation means the creation of a trust relationship between an external identity provider and AWS. And a federated user means instead of creating an IAM user, you can use your already existing identities with your identity provider, your IDP. And so really we recommend, if you're seeking to IAM users, that's only for the simplest environments where you don't, say for example, you have a single AWS account and you don't already have like a corporate identity provider, Active Directory or our partners Okta or Ping. You can also use AWS SSO single sign-on as your identity store. But really the message here is to avoid managing human users through AWS IAM. IAM users are still acceptable here for on-premise apps that need to access AWS APIs and services. And there's that case still exists. But overall, we provide a host of tools to make this really, really easy, and onto that general theme of the easier it is to manage, the less chance for issues to pop up. So having an external source of truth, your identity provider, like from your Active Directory or single sign-on, is a strong benefit for making so much easier to use and one password to remember instead of say like 20 or 30. So that keeps you secure, essentially. There's two other important use cases to mention here, which is like your mobile apps or web app access, and those should always be federated. So that's, say scalable up to like millions of users, and you can use something like Amazon Cognito, which uses like login with Facebook or login with Google, login with Amazon through the security, through SAML 2.0, that security assertion markup language. And the last kind of use case to talk about here generally is, delegating access to multiple accounts. That's going to be using federated users through assume IAM roles. And, if I get any message across here, it's never share your security credentials. It's so tempting, and even in a small, say single AWS account with multiple devs, you want to share and save, credentials into your password sharer. But please create separate users. If whatever you use, IAM users or federated users, strong preference to federated users, but please do not share the security credentials. So just to illustrate this here, this is like your corporate user federation through AWS single sign-on. And you've got your IDP, your external source of truth for all your identities, in the bottom left here. And basically your user can log in and they're presented with their password. They can access the AWS single sign-on portal. And here, this already knows which organizational unit they're in. Say they have access to their developer. They have access to say 2 AWS accounts here, and they'll see that immediately listed there in their single sign-on portal. They just one click and you can get management console access to both of those accounts. And what's also really, really cool is you can give immediate access to the business cloud apps they need, say like Slack or Zoom, and they're already logged in. They haven't entered a separate password anywhere yet. And lastly, you can extend this as well to any custom SAML applications. Say you have your own internal applications or ones that aren't listed, in the predefined lists. As long as they're SAML enabled, you can have that same single sign-on access. And real benefit here is you may have heard of password fatigue. This just gives the users a way better user experience. So it reduces that security risk of I can't manage 30 passwords properly. I mean, it's a lot to manage. So this really takes away that away. Next, this is what I mentioned, the mobile app federation, and this is scalable up to millions and millions of users. Where instead of creating millions of IAM users for all of your users, you're essentially using Amazon Cognito to manage the tokenization and the authorization here. So step one, in your mobile app or web app, you redirect your user to reuse an existing login they have, say login with Amazon, if they already have an Amazon account, and your app redirects them to exchange an ID token for a Cognito token. And this again is exchanged for an AWS security token service token. So temporary credentials are given, right? At no point are permanent credentials stored on their phone or on the device. And lastly, this temporary credentials give you access to AWS services, such as in this case DynamoDB, to actually write to your backend data store. And you can even do item level access to DynamoDB based on a Cognito ID. So really secure, just for that user to access exactly what they need to. And it's all parameterized and tokenized, and it's a really clean flow, scalable up to millions of users. So cool. Let's quickly talk about access keys and passwords. So if you have to use these long-lived credentials, I've already established just how much our strong preference for using federation or using roles for those temporary security credentials. But if you do have to use, these long-lived security credentials, let's quickly talk about these. So next slide, please. If you have an IAM user that you want to grant console access to, they must have a password created. So that is a requirement there. And if you have, say, you have to give, like my example of an on-premise application that needs to talk to AWS, you want to grant programmatic access, then that's via an access key. And that can be done via API, CLI, or SDKs. And that's where you'd give that access key access to. So in either case, whatever you do, whichever one you do need access to, you can do either or both. And make sure you do rotate the credentials regularly. So that means to inform yourselves, using the credential report, to regularly audit that, configuring that strong password policy, and configuring, the users to rotate their credentials themselves. And lastly, using our managed service AWS config for a managed rule to actually check and govern and make sure that you're governed correctly, that you're not out of compliance there. This is simply showing you a sample policy and some steps to rotate your access keys here. I won't drill into this entirely, but essentially it's how to safely retire the existing credentials and then update to use the new credentials and set the first credentials to be inactive, and deleting the very first set of credentials. So this would be created for that IAM user, and I do definitely recommend creating that config manage rule. Default is 90 days. Some companies like 180 days, etc. It is a preference there. But if we have time at the end, we'll also show you how some of this credential and that config manage rule can alert you to out of compliance configurations. So over to you, Louise.
Thanks, Aidan. So this question was asked earlier, but just to go over it again, the difference between inline policies and managed policies and when to use one or the other. So an inline policy, as I mentioned, it's a strict one-to-one relationship between the policy and the principal. So that just basically means that the policy is dedicated to that principal, whether it's a user or role, and you can't attach the policy to any other principals, which means that you can't ever attach the policy if you don't want to, like if it's wrong or anything like that. And it also means that when the principal is deleted, then the policy will also be deleted. Then a managed policy, it's reusable. So that means that if you create the policy, many different users and roles can actually use the policy. And when you change that policy, the change is applied to all principles that the policy is attached to. So that's central change management as well. And there's versioning in rollback, which means that when you actually save your policy, you have different versions of it. So if there's ever a reason why you would need to go back to a previous version, that's possible to do. With managed policies, AWS managed policies, I mentioned this as well previously, where basically you have, if there's any change, if there's any policy that needs to be updated, or if there's any new service or API introduced, Amazon takes care of all of that and they update the policies on your behalf. So there's no work there required of you. And also a larger policy size. So managed policies have a limitation of 6,000 characters, whereas inline policies are 2,048 characters. So this means that if you ever hit the limit with inline policies, we suggest switching to managed policies and adding managed policies instead. So that would be another reason as well, besides the one-to-one relationship. And when should I use identity-based policies and resource-based policies? So I mentioned this earlier when I gave the policy examples, but basically the difference here is that identity-based policies are applied, I'll start with resource-based policies. So they are applied directly to a resource. So whether that resource is an S3 bucket policy, SQS queue policy, SNS topic policy, KMS key policy, there's so many different types of resource-based policies. And you basically can control access to those resources. Then an identity-based policy is a policy that you would attach to an IAM user role or group. And this can be managed or inline, as we just saw previously. And this basically means that you are controlling what the user or role is authorized to actually do. And then the resource-based policy is controlling who has access to that resource. So they can actually work together really well. As you saw previously, there was an IAM policy for an IAM user, and there was a resource-based policy for an S3 bucket, and they can all be used together to define whether or not the user has access to the bucket. And both these types of policies can be used for same account or cross account. On to you, Aidan.
Thanks, Louise. So another big topic here is having one AWS account or multiple AWS accounts. And, really a single AWS account should be for when you are dealing with the simplest environments. And, this is when, next slide, please. This is when you have no need to isolate your projects, products, and teams, and you have no real need for needing to break up your cost if you have multiple apps and teams working in one account. What comes to mind is, say, having a dev test or like a hobby account, and or you're a contractor and you're delivering a full stack app that will be later invited to your customer's AWS organization. So those are some cases where a single account makes sense. For most customers, multiple accounts is the right way to go, and this gives you that full isolation between projects, teams, and environments. And for example, even if you have a central logging account, that gives you access to your auditing data, like writing your CloudTrail trails, and also your backups, your critical backups can be written to a separate AWS account. And this also gives you consolidated billing. You can have a payer account with nothing in it except your bill that all the other accounts are linked to. And it also helps you break out your costs. Separate business unit spent this much. What was the cost of goods, etc. So let's jump to the next slide here, and I'll talk about some cross-account access consideration. Let's say we have decided to go cross-account, and I use multiple accounts. There's two major models we see with respect to like IAM roles and federation. The first is a direct model, and this is where you have your users directly assume roles into sub AWS accounts after being authenticated from an identity provider. And the second is a hub and spoke model, where you have a central identity account and users assume federated roles first into that identity account and then perform a second role assumption into sub accounts. So I recommend the direct model for most because it's much simpler to configure and allows you to treat your corporate identity provider as the source of truth, as opposed to having access relationships defined in that one hub AWS account. It's also less of a hop. It's one less hop, assuming 2 roles to get your credentials needed for operating in that account. And even simpler, your users only need to bookmark 1 item as opposed to multiple. The hub does have its benefits, though, if you're creating lots of AWS accounts in an automated fashion. We're talking, say hundreds of accounts, and these may be short-lived accounts, like an account vending machine, for example, style that creates and destroys accounts frequently. You only have to manage and update roles in that one hub account. And really, this is if you've built a lot of strong automation to alleviate some of the added complexity and trade-offs I mentioned of the direct model. And you want to centralize access into AWS with, and you say you don't even want to use an IDP. So that's where the hub model would fit in. Another consideration is when you're mapping all of your CloudTrail events here, you have to take that little bit of an extra mental step to see which API events were created within your federated role. It also generates a much larger CloudTrail event, and that you need to factor in the recipient account ID as opposed to just seeing like the direct sample API request that's say right in your one CloudTrail bucket. So I recommend using Amazon Athena to query your CloudTrail because you can write more specific SQL queries, and a single query can span all your AWS accounts. So lastly, the last consideration here is role chaining durations. It's a 1 hour duration limit if you're chaining across accounts via CLI or API. So be aware of that, but that 1 hour duration does not apply if it's IAM roles running on an EC2 instance. So your app is running on EC2. Just a really quick illustration of cross account, the simplest example of cross account access I could find here. And we're simply here, we want the developers in the developers group to be able to access a production S3 bucket in a different account. So 3 steps, in the first part, you create a role in your production account, and this role is used to establish that trust relationship between the developer account and the production account. And you create the role, create the policy, and next you have to grant step 2, you have to grant access to this role, and you make sure that it's only specifying your developers group, not your testers group. You may have multiple groups in your development account. And lastly is to test this scenario out by switching the roles in your development account. And we've created a role, the update app role that you see here. And you can test via the console or the CLI or the API and just verify that definitely I have access to the bucket, but only for the developers group and not the testers group. And the link here has a quick tutorial on how to accomplish this in like 10-15 minutes. It's a really straightforward, simple example here. This is a little bit more complicated example of the a more fleshed out example here of the hub and spoke that I mentioned before. And here we're seeing, the central security account. We're seeing a user get authorized externally via their external identity provider. And, he does have to do the extra hop to get to his role A in a different AWS account. And the orange line you're seeing on the right-hand side there, that's an example of that role chaining with that 1 hour duration there. So just to illustrate a little bit of it, he's accessing his EC2, his S3, and his DynamoDB assets in different accounts here. Great. So let's jump to monitoring and remediation. So monitoring is all about detection and awareness, and everyone should have monitoring in place for their AWS accounts. It's a really important process. And the general steps here is like monitor, detect, and respond. And usually, remediation from the get-go is oftentimes a manual process. And this is, in my opinion, is like an evolution. And the more cloud mature you become, or the higher your compliance requirements, you work your way up to more of these automated remediation and preventions. So AWS has a number of great tools to help here, like IAM Access Analyzer to give you awareness to external principals that that are outside of your zone of trust. So outside of your AWS organization or outside of your account. So external principals. Also, IAM Access Advisor, so your last access reports in conjunction with your credential reports, really important to help you build and tighten up all of your IAM configuration. So that's awareness. What's also really important is, so CloudTrail gives you all your API access, right? You can use this in conjunction with CloudWatch alarms. So this can give you real-time awareness of all your API calls. Like, for example, someone's logged in with root. You want to be alerted of this. Or someone has disabled MFA. You want to be alerted of this. And I just want to call out, there's purpose-built services that we have, such as AWS Config for configuration rule management, Amazon Macie for S3 private information, personal identifiable information awareness, AWS Guard Duty to monitor your DNS logs, VPC flow logs, etc., and Security Hub to kind of tie everything together and aggregate. We should talk about prevention. Control Tower, we have a whole suite of also dedicated governance tools. Control Tower, service catalog, organizational secure control policies, systems manager. These are all dedicated services that help manage and give you really good guardrails here, and that's a part of prevention. But also remediation and prevention, it brings up event-driven architectures where you combine multiple services and data sources with automation. And this example, your sources could be like CloudTrail or Config. And if we go to the next slide, I can show us a really cool architecture involving remediation here. And basically, you've got new objects being written in a user portal. Your customers are uploading, say, forms for you, and this triggers a CloudWatch event, formerly or an event bridge event, formerly CloudWatch events, and that can invoke a Lambda, and this can create a sensitive this data discovery job. So you say you want to make sure that there's no credit card numbers or social security numbers or anything inappropriate in the uploads. And before this sensitive data gets spilled into, say, hundreds of servers or tons of different workflows. And also you can have SNS to inform the rest of the pipeline to stop it once the results of the Macie discovery job are there. So there's a whole reInvent video from a fellow TAM on this topic, event data-driven security using Amazon Macie. So just shout out to that in the links if this interests you, this topic with Macie. But at this point, I think we have enough time for our, let's see. Actually, Michael, do we have questions at this point? Yeah.
Let's see. So no, it looks like we have answered all of the questions. Please feel free to drop a question in the chat if I did not, or if Louise or Aiden did not. So I think we've got just enough time here to maybe squeeze in that last demo.
Great, I'll just get it up there. Okay, so here is our demo. Oh, sorry, can you see that?
Yes.
Okay. So here is our demo on config, and let me just try to get rid of that bar there for a second. Yep. So this config is our service where basically you can have, it's like a managed compliance service. It monitors and records your AWS resources configurations and allows you to create rules for evaluation, which is what we're going to be doing now on the rules page here. So what you can do is you can create a rule against your resources, and it will let you know if it's compliant with your desired configurations. So for the purpose of this, we're going to create an IAM one, and we're going to do, so you're going to go up here, click add rule, and specify rule type. So you can have AWS managed, you can have custom rules, or you can have AWS managed rules. So custom rules, like custom policies, you can make specific to your account using your own script and a Lambda function. Here we're going to use access keys rotated. So this is basically, it checks whether the IAM active keys associated with your user are rotated within a specific number of days. So let's say you want to make sure for compliance reasons that all access keys are rotated within 90 days. You can use this rule to make sure that you're compliant with this throughout your whole account for all of your users. So here we're going to create a rule, and we can specify the frequency for config to check this. So we're going to say 12 hours, and we're going to have as 90 days. So the maximum you can go without rotating your keys will be 90 days. That's the rule added there. And now we're going to add a remediation for this. So we click back into the rule, and we're going to go up to actions on the right side and manage remediation. So here you have automatic or manual remediation. We're going to click automatic, and we're going to click SNS, publish SNS notification. So what this is going to do is it's going to notify us whenever a user has gone 90 days without rotating their keys. So as you can see here, it's already pre-filled in. So here is your topic ARN for SNS and your message. So we're going to say rotate your access keys, and then also your role. So the role here is AWS service role for config remediation. And I'm actually just going to swap this out and add the ARN. This should always be the role ARN. So there we go, that's saved. And now you can see the config rule here. And this is all, so 90 days, it should be rotated. That's the maximum we can do before getting notified. And if you click into the remediation action here, it's going to show you that within 90 days, the SNS topic is going to notify you via email, that's the endpoint, that a user's keys have not been rotated. So, yeah, there we go.
All right, Louise, thank you very much, and Aiden as well, for talking to us today about AWS identity and access management best practices. We've covered a lot of different topics, from monitoring and remediation, talking about IAM users and federation, access keys, inline policies, managed policies, resource policies, identity policies, and multiple account structure. We've really covered the gamut. That was definitely a lot of content to cover, and thank you both very much for doing such a great job doing it. For all of you, if there are any questions which we did not answer today, you can post your questions on forums.aws.amazon.com or email us at the address shown on the screen there, kc-live@amazon.com. We do want to hear from you, so tell us what else you would like to see for future topics on the show. Thanks for joining AWS Knowledge Center Live. Happy cloud computing.
Thank you. Bye.